Hi, this is section 7.4, Systems of Linear Equations and More Than Two Variables. So they start us off with the definition of a matrix. So this is an M by N matrix. You can see there's M rows and N columns. The first letter denotes a row, the second letter denotes a column. And it's just a way to arrange your information. So let's look at some of the things that we can do. We can interchange two rows, and it doesn't change the matrix. It's an equivalent matrix. A row is, if you multiply a row by a non-zero constant, or if you divide it, it's still in an equivalent system. And if you multiply a constant multiple of one row and you add it to another, it also is an equivalent matrix. So let's perform some of these transformations on this matrix. So the way we set it up is you would set it up like this. We want the coefficient, so that's 1, -2, 3. The equal sign, I'm going to draw a straight line. 4. Then we got 2, 1, -4, 3, -3, 4, -1, -2. So that's our matrix. That's how you set it up. All right. Now we want to do what's called row echelon form. So this is what row echelon form looks like. You have ones along the diagonal and zeros everywhere below. And these can be any numbers. So the goal is to get this to be a 1 followed by zeros below, and then 1 zeros below, then 1 zeros below, and finally 1. So that's our goal here. So our first step is to get this to be a 1, which it already is. Now we have to make this a 0. So what are we going to do? We're going to multiply the first row by -2. Then we're going to add that to row 2, and that's going to equal your new row 2. So if you multiply this by -2, add it to this one, this will become 0. All right, if you multiply this by -2, you get 4. 4 plus 1 is 5. If you multiply this one by -2, you get -6 minus 4 is -10. And -2 times 4 is -8. -8 plus 3 is -5. All right, now we do the same thing to the third row. We want to make this a 0, so we have to multiply row 1 by positive 3. Add that to row 3, and that's going to equal your new row 3. So 1 times 3 is 3. 3 plus -3 is 0. 3 times -2 is -6. -6 plus 4 is -2. 3 times 3 is 9. 9 minus 1 is 8. 3 times 4 is 12. 12 minus 2 is 10. All right, so now we have to make this a 1. So to make this a 1, we multiply this entire row by 1/5. So 1/5 times row 2 equals row 2. So in other words, we're just dividing this row by 5. This is not going to change. 0 divided by anything is 0. So this becomes a 1. This becomes a -2. And this becomes a -1. All right, our next step is to make this a 0. So in order to make this a 0, we have to multiply row 2 by positive 2 and add it to row 3. So row 2 times positive 2 plus row 3 equals row 3. That would make this a 0. That would be -4 plus 8 is positive 4. This would be -2 plus 10 is positive 8. And finally, the final step is to make this a 1, and we multiply this entire row by 1/4 to make that happen. So multiply 1/4 times row 3, and that's going to equal row 3. So these are going to be the same. 4 times a 4th is 1, and 8 times a 4th is 2. So finally, we have echelon form. Once we have echelon form, this represents a coefficient for your z. So z equals 2. Now we write the second equation, which would be this one. The coefficient for y is 1. The coefficient for z is negative 2. So we have 1y minus 2z equals negative 1. Here's your equals, and here's your negative 1. Well, we know z is 2, so we do our substitution here. And that's going to be 4, so you add 4 to both sides, and you get y equals 3. And then the last equation is the top one. So we write out that equation. That's going to be x minus 2y plus 3z equals 4. And we substitute 2 for z and 3 for y. X minus 6 plus 3 times 2 is 6 equals 4. So once again, I just substituted 3 for y, I got minus 6, and I substituted 2 for z, and I got plus 6. So the 6's are going to cancel. So x equals 4, and that concludes this problem. So our final answer is going to be 4, 3, 2, and that's how we end it. All right, let's try another problem. So once again, this is called echelon form of a matrix. So here's our next matrix that we want to solve. So what we're going to do is we're going to draw a line, which is going to represent the equal sign. So they already put the system of equations into a matrix for us. Now we can do the same thing that we did with the previous problem. We need to get this to be a 1, 0, 0. So what I'm going to do is I'm going to interchange these rows because I want 1 to be in the top left corner. So I'm going to do row 1, interchange row 2. So that's going to change the matrix and make it look like this. We got 1, negative 2, 2, 0, 5, 2, negative 1, negative 7, 0, 3, 1, 17. All right, so there it is. So let's go ahead and do the transformation. So step 1 is that's step 1, the interchanging of row 1 and 2. Step 2 is going to be multiply negative 5 times row 1 and add that to row 2. That's going to equal row 2. So we want this to be a 0, so that's why I multiply this by negative 5 to add it to this one. That would make that a 0. For the next one, that's going to be positive 10 plus 2 is 12. For the next one, that's going to be negative 10 minus 1 is minus 11. And for the last one, that's going to be negative 0 minus 7 is minus 7. All right, so we've got 1, 0, 0. Now we have to make this a 1. So in order to make that a 1, we have to divide by 12 or multiply row 2 by 1/12. That becomes your new row 2. So that's going to be 1 there. This is going to be negative 11/12. And this is going to be negative 7/12. So you're going to start to get fractions, and it's going to look kind of ugly, and so you might need some scratch work on the side in order to, minimize the mistakes. All right, our next step is to make this a 0. That means we have to multiply row 2 by negative 3 and add it to row 3. So negative 3 times row 2 plus row 3 equals row 3. Notice that nothing happens here. Here you get negative 3 plus 3 is 0. Just going to make this red to be consistent. The next one's going to be negative 3 times 11/12. That's going to be positive 11. So here's my side work I was talking about, side work. So when you multiply that, you're going to get negative times a negative is a positive. So that's going to be 11/4 plus 1, which is really 4/4. That's 15/4. All right, the next one is going to be negative 3 times negative 7/12. That's going to be positive 7/4 plus 17. Well, 17, we need to get the common denominator is 4. So 4 times 17 is 68. 68 plus 7 is 75/4. All right, the final step is to make this a 1, and we do that by multiplying by the reciprocal. So the reciprocal is 4/15 times row 3 is going to equal row 3. And so that's going to give us 1 here. Over here, if you multiply by the reciprocal, you're going to get 4/15 times 75/4. You get 4 to cancel. And then 75 divided by 15 is going to be 5. So this is going to be a 5. So we have z equal to 5. That's our first variable. Now we have to go ahead and write the second equation out. The second equation is going to be y minus 11/12. Z is equal to negative 7/12. Let's do our substitution. Plug in 5 here. If you plug in 5, you're going to minus 55/12 equals negative 7/12. Add 55/12 to both sides. You should get 48/12, which is 4. So you get a nice looking integer there. And then the last equation will be x minus 2y plus 2z equals 0. I wrote out this equation. And let's plug in the variables that we know. We know y is 4, so that would be an 8. And z is 5, which makes this a 10. So that's going to be 2, subtract 2 to both sides, you're going to get negative 2. And that concludes that problem. So we have x, y, and z. Okay, the next example. So this one is missing an x coordinate, but that's okay. But we set it up. All right, so to make this echelon form, we need to make this a 0. So let's multiply row 1 times negative 1, add that to row 2, and that's going to equal your new row 2. So let's write this out. Okay, 1, negative 1, negative 4, 0, 1, 1. All right, so if you multiply this by negative 1, add it to this, it's going to become 0. Whoops, didn't mean to do that. Let's try that again. So that would become 0. This would become 0. This would become 2 minus 4 is negative 2. And that's going to stay 0. All right, our next step is to make this a 1. But the only way we can do that is to interchange these two rows. So let's do that. Row 2, interchange with row 3. All right, so let's see. That's going to be 1, 0. That's going to be 1, negative 2. And of course, the zeros doesn't make a difference when you interchange the zeros. All right, so that's the new problem. And the final step, since this is already 0, is to make this a 1. In order to make that a 1, you multiply by the reciprocal, which is negative 1/2 times row 3 equals row 3. So that's going to change this to a 1, and nothing else will be affected because the rest of the numbers are zeros. Okay, so now we can write out our equations. Z equals 0 is our first variable. The second equation will be x plus z equals 0. And since z is equal to 0, that means that y equals 0. And lastly, x plus y minus 2z equals 0. Y and z are both 0, so that means x equals 0. So we have our solution. Our solution is 0, 0, 0. Let's take take a look at this one. This one only has 2 equations instead of 3 equations. So the best we can do is make this a 1, 0, 1. That's the best we can do. So let's make this a 1. All right. First, I'm going to copy that matrix so I can erase. All right, so step number 1 has to be to multiply reciprocal, row 1, and that's going to equal row 1. So that's going to be a 1. That's going to be a negative 1/2. This is going to be a 2. And this is going to be a 4. All right, the next step is to make this a 0. So we're going to multiply row 1 by 3. Add that to row 2, and that's going to equal your row 2. So that's a 0. The next one would be negative 3/2. So I'm going to need some side work, some scratch work. All right, so if you multiply, you're going to get negative 3/2 plus 1, which is 2 over 2, which is negative 1/2. Oops, wrong color. All right, the next one's going to be 2 times 3 is 6. 6 minus 2 is 4. And then the last one would be 3 times 4 is 12. 12 plus 5 is 17. All right, the next step would be to make this a 1. So that means we're going to multiply by the reciprocal. So it's going to be 2 times R2 is equal to row 2. So that's going to be 1. It's going to be negative 8. And that's going to be negative 34. So that's as far as we can go with echelon form. Now we can write out the 2 equations. The first equation will be the bottom one, which is y minus 8z equals 34. In this kind of situation, when you have 2 equations, you need to parameterize your variable z. So what we're going to do is we're going to parameterize it. We can use the letter c. C is going to stand for constant. So z can be any constant c. That's parameterizing the variable c. Now we can do our substitution. So that's going to be y minus 8c, not z, is equal to negative 34. And now all we have to do is solve for y. Add 8c to both sides. Y equals 8c minus 34. So it's going to be in terms of the variable c now, which is actually a constant, not a variable. All right, the top equation becomes x minus 1/2 y plus 2z equals 4. If we substitute the values for y, it would be x minus 1/2 parentheses 8c minus 34 plus 2c equals 4. Distribute, that becomes x minus 4c plus 17 plus 2c equals 4. That's going to be x minus 2c. If I subtract 17, I'm going to get negative 13. And now I can just add 2c both sides, and so I get 2c minus 13. So our final answer is going to be 2c minus 13 is our x, 8z minus 34 is our y, and c is our z. All right, the last problem is a word problem. It's a swimming pool can be filled by 3 pipes, A, B, and C. Pipe A alone can fill the pool in 8 hours, and pipes A and C are used together. The pool can be filled in 6 hours. If B and C are used together, it takes 10 hours. How long does it take to fill the pool if all 3 pipes are used? So we're going to use the relationship that rate times time is equal to work, the amount of work that the rate is that these pipes are doing. All right, so the rate is A, B, and C. So let's see. Pipe A alone can fill the pool in 8 hours. So the A is our rate. And it takes 8 hours, and it'll fill up the entire pool. So I'm going to call that 1. which is going to represent like 100% of the pool. So that's the amount of work that it completes. It completes the entire, fills up the entire pool, which I'm calling that 1, which represents 100%. All right, the second equation says A plus C. A and C are used, so that means A plus C, in parentheses, is the rate. The time it takes is 6 hours to fill the entire pool. And then if B and C are used, that takes 10 hours to fill the entire pool. And now we have A equals 1/8. And we have A plus C equals 1/6. And we have B plus C equals 1/10. So we're going to do substitution. We're going to call that 1/8. So now we have 1/8 plus C equals 1/6. If you subtract 1/8, you're going to get C equals 1/6 minus 1/8. The LCD is going to be 24. So that's going to be times 4 times 3. So C is going to be 4 take away 3 is 1. 1 over 24. And now we have B plus C. C is 1 over 24 is equal to 1 over 10. Subtract 1 over 24 to get LCD, I believe, is 120. So we're going to multiply the top and bottom of this one by 12. And this one by, what is that, 120. It's going to be times 5, actually. Times 5. So that's 12 take away 5, which is 7 over 120. So the question is asking, how long does it take to fill the pool if all 3 pipes are used? Well, now we know the rates of each of the pipes. So what we're looking for is A plus B plus C times what amount of time does that take to fill the entire pool? And if we divide, we're going to get 1 over A plus B plus C. All right, well, let's see what the LCD is. The LCD is going to be 120. So 120 divided by 8, it's going to be times 15. It's going to be 15 plus 7, because that's times 1. And then over here, times 5. So that's going to be plus 5. So we end up with, what is that, 27. So the reciprocal is going to be 120 over 27. That's the amount of time it takes. And so if we convert that to a decimal, that would be approximately 4.4 hours. That's how long it would take to fill up the entire pool if all 3 pipes are turned on.